Multi-exit discriminator. In this section, we'll talk about MED attribute, which is an optional non-transitive attribute, and is going to define how the traffic should enter the autonomous system number. Like, let us make one simple scenario to understand how the and where, when and where MED attribute is more applicable. Like, take an example. In my scenario, this is my autonomous system number, and I want to ensure that all my traffic leaving the autonomous system number should be preferred over this link. Maybe by default it is using some other route, and the reason for that is maybe this is your high-speed link and the other link which is just an 1 Mbps link, and I want to ensure that all my traffic should exit via this side. So to make this possible, what I can do is I can go to this router and I can apply the weight on this side something higher than this side, or I can also use local preference attributes. Now both attributes will satisfy my requirement. Now in my scenario, let's say I have configured the weight on this side as 4000, and or whatever the traffic exiting my autonomous system number is preferring via this route. But now what about the return traffic? Now when I'm applying the weight or the local preference, it's going to do half of our job, which means our job is to ensure that our traffic leaves from this side, whereas maybe or may not be the traffic coming back from this AS, it might be using alternate route because of the default path selection process which is inside the remote autonomous system number. Now what I want to do is I want to ensure that the return traffic also should use the 8 Mbps link. So I want to do that. So to make this possible, what I can do is I can configure, if I have a control over this AS, I can configure the local preference or weight again on this AS, and saying that whatever the traffic leaving this autonomous system number should prefer this link. That is one possible solution we can do, but you may have some limitations. Might be you don't have any control over the remote autonomous system number. Now by sitting in our autonomous system number, we want to ensure that the path manipulation, means the return traffic, also should use this path. That's how the traffic should enter into our autonomous system number. Now in this type of scenarios, we can use either one attribute which we already discussed in our previous sections. We can use something called AS path prepending. So we can increase the AS hops on the other end so that this route is more desirable, or even we can use something called MED or multi-exit discriminator attribute. Cisco call it as metric in Cisco terminology or Cisco IBase, but we call it as MED. So what I can do is I can apply MED value on both the sides. It's not exactly both the sides. By default, the MED value will be 0 on both the sides, the metric, and I can configure the metric on this side lower than the other end. So let's say it is still using the default MED value of 0, and on the other side I have configured the MED value of 200. So on the router A, I'm going to configure MED value on this side something higher than the other side. Default is 0, and here we are applying higher, that is 200. Now MED is an attribute which is used, the default metric is 0 here, and it's an attribute which is advertised to eBGP neighbors. Local preference weight will not be advertised to any of the eBGP neighbors, but MED is an attribute which is advertised to eBGP neighbor, which means whatever the routes getting advertised from this side will be advertised with MED value of 200, and we are applying on the out direction. We'll see practically also in our next video. Now router A is going to receive a specific routes with the MED value of 200, and when it is doing the default path selection process, it's going to see the MED value on this side is 100 and this side is 200, and it's going to use this route as a default exit path. So that's what we call as the return traffic. Okay, but there is one more thing we need to consider when we are using the MED or metric. It's a weak attribute or a weak metric, because in case if this autonomous system number is also configured with local preference or weight, and also we are manipulating the weight, manipulating the metric also, this side is 0, this side is 200. If a weight is configured or local preference is configured, still local preference and weight is more desirable because they are a better metric in the BGP path selection process than MED. Because if you know the default path selection process, if I just list out the default path selection process, weight is most desirable and the next is local preference. And if you see MED is verified on this side. That is one consideration we need to keep in mind when you are doing that AS path. When you are modifying the MED, we need to ensure that the autonomous system number is not using any weight or local preference. We are assuming that it's not using it. If they are using weight or local preference, we don't get the desired results. And the one more thing we need to consider is the autonomous system path information, because if you see here, AS path information is even before verified than MED. So which means if you want to ensure that the return traffic, like return traffic should be preferred from this side, that is 8 Mbps link, rather than preferring your 1 Mbps link, we are going to assume that there is no local preference and no weight is applied in this autonomous system number. At the same time, the AS path information also, either it should be same, or we can also ignore AS path comparison. So for that, we need to configure some command called BGP best path, AS path ignore. There is some commands. We'll see that practically there are two possible solutions. We can ensure that both the autonomous system path is same, or we can also configure to ignore the autonomous system path and always compare MED value when deciding to exit their autonomous system number. But the good thing is we are actually configuring in our AS, and we are affecting the remote autonomous system number. We are doing some path manipulation on the remote autonomous system number. So that's the reason we call it as weak attribute, because it's more it is verified after verifying the local preference, weight, and autonomous system path information. So lower MED value is always more preferred, and that too if you don't have weight, local preference, and AS path, or it can be same in general. And MED value is not propagated outside the receiving autonomous system number. Now the meaning of this point is here, let's say on my router I have configured weight or MED value actually 200, and now this C router is going to receive that MED value, and it's going to propagate that information within the same autonomous system number, but it's not going to propagate that information to another autonomous system number. So it will be more within that autonomous system number. So unlike AS path, now that is a major difference between AS path attribute and MED. MED is propagated only within the same autonomous system number, whereas AS path information, if you do AS path prepend like we did in our previous scenarios, it's going to propagate to all the different autonomous system numbers. So when we say MED and AS path prepend, which we used in our last scenarios, both are generally used for the same purpose. Okay. And the main reason is it's going to decide how the traffic should enter into our autonomous system number. And in both the cases, list value is more preferred. Okay. And the only difference between these two attributes is the AS path information will be propagated to all the remote autonomous system numbers, but MED will be propagated only within that autonomous system number. So we'll get into more in detail with practical scenario where we'll configure weight on this side. In our next video, we'll discuss more in detail on this. We'll configure weight on this side so that it prefers, I think, on this side, and then we'll ensure that our traffic goes from this side, and then we'll also do some path manipulation, MED verification practically. Okay, so this will be our lab scenario where I'll be using our MED attribute, and I'm going to ensure that all the traffic entering into my autonomous system number should be calculated based on MED attribute.